Understanding precedence relationships in projects. As a motivating example, we will consider projects that are part of developing a Dragonfly unmanned aerial vehicle. Currently, we are in a situation in this example where a prototype has been completed, and we now need to create a proposal for commercial development. So the project that we are now thinking about has 10 activities that are listed in this table here, right? So we have the symbol of the activity from A1 to A10, some description of the activity, and expected duration in days. If you look at the sum of durations, it's 95 days. If you look at the longest of those activities, it takes 21 days. So the questions that may arise is, right, if the total number of those activities is 95 days, will this project take 95 days to complete? And the answer to this is maybe not. Maybe some things could be done in parallel, right? Maybe I can do some activities at the same time by different people, right? So using different resources, and therefore I can parallelize some of those activities. If I were to do all those activities in parallel, then, right, the longest activity time would be the limit. So it would be like 10 different people, each of them doing each of those activities in parallel. Then I could even reduce the duration of this project to 21 days, right? However, neither of these is a correct answer, because these activities have some relationships one to the other, in a sense that one activity, some of those activities require other activities to be completed before, and the precedence relationships can be expressed in a matrix format, right, as an incidence matrix, which says here, right, that activity 2 requires, X indicates that activity 2 requires activity 1 to be completed first. Activity 3 requires activity 2. Activity 4 also activity 2, and so on, right? So if we say, right, we see before you prepare and discuss surface models, you need to first prepare preliminary functional requirements. And before you do 3 and 4, perform aerodynamic analysis and evaluation, and create initial structural geometry, you need to first finish activity 2, which indirectly requires activity 1 to be completed, right? But activities 3 and 4 can be done in parallel, as we see from this matrix, right? Activity 3 doesn't require activity 4 before, and then activity 4 only requires activity 2, doesn't require, there's no X here, right? So this is one way to represent precedence relationships. Another way is to put them in a network representation. We call this activity on node, because each activity, you see A1, A2, A3, and so on, they are on nodes, and the arrows indicate that activity 1 has to be performed before activity 2 is started, and then activity 2 has to be finished before 3 and before 4, and you see the same relationships are represented in this network.